Hello friends. So today we'll discuss on one of the important performance tuning technique in Informatica. So that is the pushdown optimization technique. So today we'll discuss about one of the important technique, that is the pushdown optimization. And before we go to the what exactly is the pushdown optimization technique in the Informatica cloud, we'll discuss about what exactly is the performance tuning technique in Informatica, concept of the performance tuning in Informatica. Then we'll discuss about the what exactly is the pushdown optimization. Then different types of pushdown optimization we'll discuss. Then we'll discuss the cases where the pushdown optimization cannot be supported. And at the end, we'll discuss about the demonstration regarding the pushdown optimization. Okay, so in the demonstration, we'll run the session or mapping configuration task, that is MCT, by applying the push down optimization, and then we'll also run the session without applying the push down optimization, and then we'll compare the result, and then we'll see uh, how the push down optimization helping to increase the performance or to run the job within a less amount of time. Okay, so before we go to the what exactly is the video, first we'll discuss about regarding performance tuning concept or technique in case of the Informatica. Okay, so if you see the definition, if the goal of performance tuning is to optimize or improve the session or MCT session, or we'll call the session as a MCT also, mapping configuration task. So to optimize or to improve the session performance by eliminating the performance bottleneck to get a better acceptable ETL load time. Okay, so what? So we'll try to understand this definition by dividing it into the sub parts. Okay, so main aim of the performance tuning is to what? To get the particular job or to execute the particular job with acceptable, as here you can see, the better acceptable ETL load time. So what exactly mean by the ETL load time and better acceptable ETL load time? Okay. So if you see what exactly is the meaning of ETL load time. So ETL load time is simply nothing but what? Suppose ETL load time is simply the time which is required to load the data from source to the target. That is being referred as a ETL load time. Suppose I mentioned here ETL load time is simply what? The time required to load data from source to target. Okay, so that is called as a ETL load time. Okay, and now what exactly mean by this definition says, as I mentioned, keep better acceptable ETL load time. So main aim or the reason for which we are applying the performance tuning technique is what? Which, uh, we should get the better acceptable ETL load time. Now, what do you mean by the better acceptable ETL load time? Now, you understand, I hope you understood about the what exactly mean by the ETL load time. Okay, now what exactly is the better acceptable ETL load time? So, better acceptable ETL load time means what? Suppose, uh, let me give you the example. So, we run the session without any performance tuning technique. Okay, this is the one case, and we run the particular MCT or session with some performance tuning technique. Okay, so any performance tuning technique, we can suppose we can take the example of pushdown optimization technique. Suppose here, when we run the session without any performance tuning technique, you run the particular job one, and it took 10 minutes. Okay, so your ETL load time here is 10 minutes. Okay, and then you run the same job, but this time you run the job by applying some performance tuning technique, and here it took 5 minutes. So here your ETL load time is 5 minutes. Okay. So if you compare this ETL load time, okay, if you compare this ETL load time with this, then we can easily see this ETL load time is less as compared with this. Okay, so here when you apply the performance tuning technique, it is taking the 5 minutes, and without any performance tuning, it is taking the 10 minutes. So this is called as a better acceptable ETL load time. Okay, so that's why here you can see I have mentioned the definition. The goal of the performance tuning technique is to optimize or improve the session performance by eliminating the performance bottleneck to get a better acceptable ETL load time. Now you have understood what do you mean by the better acceptable ETL load time. Now let's discuss about how we can achieve this better acceptable ETL load time. Okay, and in order to achieve this better acceptable ETL load time, we are applying the performance tuning technique. Now, what exactly this performance tuning technique does? This performance tuning technique eliminates the performance bottleneck. Okay, so main work which is done by the performance tuning technique is what? Eliminating the performance bottleneck. So, what do you mean by the elimination of performance bottleneck? Elimination of performance bottleneck is what? So bottleneck in the performance is what? Here I have mentioned a bottleneck is a point of congestion in production system that slows or stop the progress. Means some kind of what we can say some kind of particular blockage in particular your transformation logic or in your mapping or session because of your time required for the ETL load is increasing. Okay, so that particular blockage is referred as what the bottleneck, or that particular congestion is referred as a bottleneck in your particular production system or in your session or mapping. Okay, so when you apply the performance tuning technique, we'll try to reduce this performance bottleneck. We'll try to reduce this congestion. We'll try to reduce this blockage part because of which our ETL load time is getting increased. So if you reduce this or if you eliminate this performance bottleneck, then definitely our ETL load time will decrease. And if your ETL load time will decrease, then it means that your performance has been increased. Okay. So bottleneck is nothing but any point of congestion or something which is uh, something which is affecting the particular ETL load time. Okay, so that is the meaning of bottleneck. Okay, so now in case of Informatica, the bottleneck can be present at various point. Like bottleneck can be present at the mapping level, at the stitching level, at the transformation level. Okay, so here I have mentioned some of the examples of the bottlenecks. Okay, so already I explained you what exactly mean by the bottleneck. So bottleneck is simply nothing but what? Something which is blocking the particular mapping or session, and because of which your ATL load time is increasing. Okay. For here I have mentioned a bottleneck is a point of congestion in a production system that slows or stop the progress of your mapping session or workflow. And if such kind of bottleneck slowing down your mapping session progress, then definitely your ETL load time is going to be increased. And if your ETL load time is increased, then it means your performance of your particular asset is going to be decreased. Okay. So main aim in case of when you run any Informatica job, the main aim is what? How we can execute that job within a less amount of time. So if there is some kind of bottlenecks or there is some kind of blockage, then our performance or ETL load time will always get increased. Okay, so main aim of the performance tuning technique here is what? To eliminate this different kind of bottlenecks or blockage or something which is slowing down the performance of your mapping or session. So now what are these different kind of bottlenecks? Okay, or blockage. So as I said, bottlenecks are present at a different point in your mapping or in your transformation. Okay, so for example, in expression transformation, there is some different kind of inbuilt functions are there, like is spaces, is number, if, decode. So these are being considered as a bottleneck, because of which the performance get reduced. Okay, if you have utilized this kind of functions in your expression transformation, then definitely the ETL load time always get increased. Okay, so whenever possible, we should avoid to use this kind of function in order to get the more performance or in order to achieve the performance tuning. Okay. Then also there is some operator like whenever you want to concatenate, we use these functions. Okay, so this function always take more time to execute as compared with this particular operator. So for concatenation, it is always better to use this operator as compared with this concatenation function. Okay, so if you use this operator instead of this, definitely your performance will get increased, your ETL load time will get decreased. Okay, then in order to improve the performance, we have to try that the precision should be less. Okay, we have to avoid the high precision data types, because what happens, high precision data types always slow down the Informatica server. Okay, so whenever it is whenever it is case that there is no need of the high precision, we should disable high precision in order to improve the session performance. Okay, then like that also, when we are using the various transformation in your mapping, we also in some cases we also need to use the store procedure. Here store procedure also reduce the performance, so we have to avoid the store procedure. Okay, if it is not mandatory to utilize in the mapping. Okay, and then if there is a single mapping contains many targets, okay, then instead of applying such kind of logic and executing the asset, we can divide this particular single mapping multiple targets into the separate mappings. Okay, separate mapping in the sense instead of having the multiple targets in the single mapping, you can divide them into the separate mapping and improve the performance. Okay, so meaning of this last statement is what? We can simplify the mapping instead of the complicating the mapping by having the multiple targets within a single mapping only. So instead of having the multiple targets within a single mapping, we can divide that particular mapping. Okay, and having the individual targets for each pipeline. Okay, so that also increase the performance. So these are the just some example of bottleneck I have mentioned here. Like that, there are various kind of bottlenecks. Bottlenecks can be present at the database level, at the session level, mapping level, transformation level. So here I have mentioned some of the transformation level and the mapping level kind of bottlenecks. Okay, so if such kind of bottlenecks are present in your asset or mapping or session, then definitely it slows the performance of your asset, and because of which the performance of your particular system get affected. Okay, so that is nothing but exactly what is the performance tuning. So I hope you have got the definition. The goal of the performance tuning is to improve the or optimize the session performance by eliminating the performance bottleneck to get a better acceptable ETL load time. So we have to eliminate the particular certain things which is part of your mapping. So we have to eliminate the certain things which is part of your mapping, which is slowing down the performance of your mapping. Now, what can be this kind of things or bottlenecks? So these are different kind of bottlenecks which can slow down the performance. So eliminating this and getting the better acceptable ETL load time, that is the simply concept of what I said, the performance tuning. Okay. So now let's go to the what exactly is the performance tuning technique, that is the push down optimization. So there are the various performance tuning techniques, and one of that is the PDO, which stands for the push down optimization. Okay. So here I have mentioned the push down optimization is the concept using which you can push the transformation logic on the source or target database side. Okay. So what exactly mean by the pushing the transformation logic on source or target database side? It means that instead of your particular transformation logic, instead of your transformation logic being get executed by the data integration server, what happen in the pull down optimization? Your transformation logic is executed by the source or target database itself, means database server itself. So that is being referred as the pull down optimization technique. Okay. So here I have mentioned the pull down optimization is a performance tuning technique. The transformation logic is get converted into the SQL queries and pushed towards either source database or target database. Okay. So when we apply the pull down optimization, what happens? The transformation logic not get executed by the data integration server. Instead of that, your transformation logic is get converted into the SQL queries, and it is pushed towards the either source database or target database, and then it get executed by that database server. For example, your source database is the Oracle. Okay. Then your transformation logic will be get converted into the SQL queries, and this will get pushed towards the source database, that is the Oracle database server, and then Oracle database server will execute your transformation logic. So what happened in the pull down optimization? Instead of your transformation logic get executed by the data integration server, your transformation logic is getting converted to the SQL queries, and it is being get executed by the particular database server which is present at the source database or which is present at the target database. So that is the simple concept of pull down optimization. Here what happened? Stop your transformation logic get executed by the data integration server. Instead of that, it is get executed by the database server which is present at the source side or which is present at the target side. So that is the simply concept of push down optimization. Okay. So here also I have written some other description related to the push down optimization. So certain mapping, generally what happen, why there is a need of what we can say the performance tuning or the push down optimization is what? There are the certain mapping which generally takes a huge amount of time for the processing. Okay, like we have the different SCD2 types of mapping, which generally require the which generally require the more time because it has to process the huge amount of data. Okay, and it has to compare the huge amount of data with the existing data. So in such kind of mapping, the time requirement or ETL load time is generally high. So in such kind of mapping, then we can apply the performance tuning technique like the pull down optimization. And because of pull down optimization, we can reduce the time required to execute the job 10 times faster. Means suppose if there is some mapping which is taking the 10 minutes to execute, and if we apply the pull down optimization, we can reduce this particular time of ETL load time around 1 to 2 minutes. So that is nothing but the power of pull down optimization performance tuning technique. Okay. So even we can take a simple example like instead of executing your job on the data integration server, if that job get executed on the database server, then definitely the time requirement for execution of the job on the database server is always less. Okay. So here I have mentioned one example. When we convert some table into the query, and then also we can get more performance using the query option, because query run directly into the database instead of Informatica uh, data integration server. Okay. So what I'm trying to say here, suppose uh, let me take you to the mapping. Okay, when the mapping I will show you. Okay, so we'll take example of simple filter, and I will show you how when you convert the particular query into the if you convert the particular table into the query, so we can get the better ETL load time. Okay, and if you use the particular filter transformation, so you can get the ETL load time, and then we will compare this to ETL load times. Okay, so this is the mapping where you can see I have used the filter transformation. Okay, and I have applied the filter condition here. Okay, and I have some data also. So this you can see I have the table. Okay, let me show you the table also. Okay, and I have another mapping with the same table. Okay, here you can see the my table is the video source. Okay. Now here, if you see this one, this mapping, I have used the table video SRC, and I have applied the filter transforms. And I have another mapping, okay, where I have used I have converted a particular table into the query, and I have given the filter in the query itself. Okay. Now, I will show you, I already ran this mapping. Here I will show you which mapping is taking how much time. Okay, let me first show you the table. So let me show you the table, and how much data is there in the table. So here is my table PDO SRC. These are the fields in the PDO SRC: current key storage, current ID, table name, and this is the data. Okay. So if you want to see the total data inside this table, it's from PDO SRC. You can see the total amount of data, the rows inside this table is 2,30,475. Okay. So this amount of huge amount of data is there. Okay. Uh, Now here is the mapping. Here you can see here I have used the table video SRC, and here I have applied the filter transformation. Okay. And I have created another mapping where I have not used the table. I have used the query. So definitely in this mapping where we have converted the table into the query, we should get the less ETL load time as compared with this mapping where we have used the transformation logic. Okay. So let me show you M filter. This already I have ran because it takes the time to uh, run this mapping. So let me show you the time required for this. You can see, sorry, show you here. So here, this is the first one. So here you can see the time required for this mapping to run was 38 seconds. Now let me show you the time requirement without filter transformation. So here I can show you the time requirement without filter transformation. So let me clear this. So can filter without transformation. You can see that 35 seconds only we have required. Okay. So from this we can easily compare the, if you ran the particular mapping by converting it to the query instead of using the table, we can get the better ETL load time. Okay, as compared with having the transformation and having the table. Okay, so when you use the table, then you can see the data goes to the next transformation here. This transformation will get executed at the data integration server side. Okay, but here you can see the transfer here on the servers, on the source side only we have used the query itself. Okay, and not the table. So this will get executed on the database server side and we'll get the less ETL load time. So this is also the one of the example of performance tuning. Okay, so as you can see, whenever it is possible, we should utilize the query instead of table. So if you use the query instead of table, you can uh, you can filter out the particular data on the source side itself instead of using the filter transformation here. Okay, so that is the one of the technique. Okay, where whenever it is possible, we should convert the table into the query at the source side only, so that we can get the better ETL load time. Okay, so likewise, the same thing uh, we try to achieve in case of the push down optimization. Okay, so already I have mentioned you what exactly the push down optimization. So in the push down optimization, what it does? So in the push down optimization, it converts the particular transformation logic into the query and then push that particular query on the source or target database side, and then that source or target database server will execute your query. Okay. Now let's see the next part about the push down optimization. So definition already I told you what exactly is the push down optimization. So push down optimization is one of the predefined functionality in the Power Center and in the IICS. So this is a predefined functionality already available. So which convert your single set of transformation into the query and execute it at the database level instead of at the IICS level. So which will improve the performance drastically, or which will improve the performance uh, uh, in very large amount, we can say. Okay. So push down optimization increase the mapping performance when the source database can process the transformation logic faster than the data integration service. Okay, so main idea behind the push down optimization is what? So what happen when you apply the push down optimization? The transformation logic get executed on the source database side or on the target database side, and because of that, the processing happen faster as compared with the processing happens at the level of data integration service. Okay, so because of that, we get the more performance. Okay, so here I can see what happened when we apply the push down optimization. The entire processing which is happening at the IICS level will get converted into the query and will get executed at the DB level. So this is the main idea behind the pushdown optimization. Okay, so whatever the transformation we have used, instead of that transformation will get executed at the data integration service. Instead of that, different transformation logic get executed at the data integration server, that will be get converted to the query and that will get executed at the DB level. Okay, so that exactly is the push down optimization. Okay, so in the whenever you use the push down optimization, we can also parameterize the video types. Okay, I will show you in the demonstration. So there are the different type of push down optimization. So through the parameter file also, we can pass the type of the push down optimization that you want to perform. Okay, so if source and target side having the different connection, in the sense if the source is having the different database and target is having the different database, then in order to perform the push down optimization for such case, we need to add a certain property at the session level. So that properties allow push down for user incompatible connection. Okay, that I will show you when I will demonstrate you the push down optimization. Okay, so generally the push down optimization gives the better performance when the source and target both are having the same kind of database. Okay, so okay, generally performance we can achieve the great performance or good performance if the source and target side database is same. But if the source and target side database are different, then in case of this, we have to apply this particular property at the session level. Okay, and when we apply the push down optimization, we can check the session logs. Okay, to verify whether our push down optimization has been done successfully or not. Okay, when we run the session, I will show you the whether our push down optimization has been done successfully or not. Okay. Now let's come to the next point regarding the push down optimization. So as I said, there are the various types of the push down optimizations are. So generally and mostly utilized push down optimization is the full video. So it stands for the full push down optimization. Okay. So applying the video from source to the target. So what exactly is the push down optimization? So push down optimization is simply nothing but applying the push down optimization from source to the target to all the transformation. And if you apply the full push down, every transformation will get optimized. For this transformation, which is part of the mapping, that all the transformation must be supporting the push down optimization. Okay. So when we apply the full push down optimization, all the transformation which is part of your mapping, that all the transformation will get optimized, means that all the transformation will get converted into the SQL queries. But the important thing here that you should note down is what? That all the transformation must be supporting the push down optimization, because there are some transformation which there are some transformation which don't support the push down optimization. Okay, so we'll see which are the transformation which are unsupported by the push down optimization. Okay, so this full push down in the sense uh, we apply the push down from source to target to all the transformation. That is the meaning of full push down optimization. Okay, and all the transformation will get optimized when we apply the full push down optimization. And here the thing is what, or particular what you can say, the restriction is what, all the push down all the transformation must be supported by the push down optimization. Okay, so that is the important thing. If there is some transformation which doesn't support the push down optimization, now in case of that particular transformation will not be get converted into the particular SQL queries, and that will not get executed on the database side. Okay. So here I saw also some other points I have mentioned. The integration service pushes as much transformation lag as possible to the both the source and the target database. Also, the source and target must be on the same database. So there is a requirement that your source and target must be on the same database. So if they are not on the same database, then we have to use the property at the session level that I told you. This property we have to mention, allow push down for user incompatible connections. Okay. So important thing, if your source and target are not on the same database, then the performance of the video uh, not be as good as if we have the source and target on the same database. Okay. So try to apply the full video when you are having the source and target on the same database. Okay. So generally, when you apply the full pull down optimization, as I have mentioned here, your transformation logic is pushed on the source and target database, but generally your transformation logic get pushed towards the target database. Okay, I will show you in the transformation. I will show you in the logs also. Okay, so it may be possible that your transformation logic may be pushed toward the source, or it may be pushed toward the target. Okay, so both of the situations are quite possible. Okay. Then, as I mentioned, the full push down optimization is ideal when the source and targets are in the same database. Already I mentioned. Okay. So, or when the transformations such as aggregator, filter transformation are processed in the source database and reduce the amount of data to be moved. Okay. So, ideal situation in the sense we can get the better performance when your source and targets are both in the same database. Okay. So that we'll see in the demo also. So this is the first type of the full push down. This is the first type of push down optimization. That is the full video. So in the full video, what happened? All the transformation will get optimized. Okay, that is the one important thing. Another thing, your transformation logic may get pushed toward the source or target database. May get pushed toward the source or target database in the sense your transformation logic may will get your transformation logic will be get executed by the source database or by the target database. That is the meaning of pushing your transformation logic to the source or target database. Okay. So and another important thing is what we can get the good result when source and targets are both in the same database. So these are the three important things related with the full pull down optimization. Okay. Then next we have the partial PDO. Okay, the partial PDO that stands for the partial push down optimization. So nowadays, this particular push down optimization not supporting. This is not supported in the IICS now. Okay, so still the research is going on partial push down optimization. Currently, it is not supporting in the IICS. Okay. In future, it might be possible that it will also support in the IICS level. Okay, partial pull down optimization. But currently, I will show you in the demo also. This option is not applicable. Okay, in Informatica Cloud. So what exactly mean by the partial PDO? So this partial PDO, from the name only we can understand. Partial PDO in the sense, this video only apply push down optimization on the certain transformation. Means this push down optimization cannot be applied on all the transformation which is part of your mapping. Okay, so this will be applied only on the transformation which are supporting the video. Okay, and what about the other transformation? The other transformation will get excluded. Means the transformation which are being supported by the video that will be get optimized, but the transformation which are not supported, which are not supporting the down optimization, transformation will get excluded. Okay, that transformation will not get optimized. Okay, so that is the reason this is not effective as the full push down optimization. So that's why I said the mostly utilized optimization is the full push down optimization. Okay, so in case of this push down optimization, IICS will automatically determine which transformation can be optimized and which cannot be optimized. But currently, this is not being supported in the IICS. Okay, in the future, it might be possible to apply the partial PDO in the IICS also. Okay. Then we have the third type of push down optimization, that is the source side push down optimization. Okay. So source side push down optimization means what? When we apply the source side push down optimization, what happens? All the transformation from source, to the transformation just before the target all get optimized. So here what I have said, applying the video, when you apply the source side video, what happen? The pull down optimization will get applied to the all the transformation from source to all available transformation and eligible transformation, excluding the target transformation. It means what? When you apply the source side optimization, the push down optimization will apply to the all the transformation, excluding the target transformation. Okay, so let me show you in the mapping what is mean by the source side push down optimization. Okay, let me clear this. So let me open the session where I have applied the push down optimization. Okay. So this both the session I will show you. Okay. So source side push down optimization means what? When you apply the source side push down optimization, all the transformation from source and all the transformation next to the source, like here expression filter, all will get optimized with the help of the push down optimization, but target will not get optimized. That is the meaning of source side push down optimization. Another type is what? Another type we have the uh, target side push down optimization. So target side push down optimization means what? Apply the PDO to all the transformation from target to all the available and eligible transformation, excluding the source. Means what? Let me show you here. So when we apply the uh, target side push down optimization, the push down optimization will get applied to the target, then to the filter, then to the expression, but it will not get applied to the source. So that is called as the target side push down optimization. Okay, I hope you have got the source side push down optimization and the target side push down optimization. Source side means what? All video, the optimization, push down optimization will apply to the all the transformation from source to the all the transformation next to the source transformation. Or you can say when we apply the source side video, all the transformation will get optimized, excluding the target. And when we say the target side push down optimization, it means all the transformation will get optimized, excluding the source. Okay, so that is the types of the push down optimization. Okay, so there are the four main types of push down optimization we have seen. The full push down, where the PDO will apply to the all the transformation from source to the target. Then partial, where the transformation which are not supported will get exclude, and transformation which are supported will get optimized. Then source side, the push down optimization will apply to all the transformation excluding the target. Target side video, in the sense the push down optimization will apply to all the transformation excluding the target. Okay, so I hope you have got the clear idea about what exactly the source side optimization, regarding the types of the optimization. Now let's go to the another important point, that is the cases where the pull down optimization cannot be supported. So one of the important thing that you should note down is PDO cannot be applied to the flat file. Okay, because you know we cannot execute the particular things which are in the form of flat file on the database server level. Okay. Then another next important case where PDO not supported is PDO also not support the expression which are containing the complex expression like set variable, set max variable, set min variable, and some important functions also I have shown you, like is spaces, is number, like that kind of things. Okay. Also, XML transformation also doesn't support the pull down optimization. Then pull down also so optimization also not support for the one source and the multiple targets. Okay, means what? Suppose there is a one source, then we have the certain transformation, and then we have the multiple targets like this. Okay, like T1, T2, T3. So in this kind of situation, the push down optimization also doesn't support. Then also lookup transformation, returning the multiple matches, also not supported by the push down optimization. Then we have the normalizer transformation also not supported by the push down optimization. SQL generator also not supported, and some other important function which are there in the expression transformation like init cap or ltrim, rtrim. So these are also not supported in the push down optimization. So currently, these things are not supported in the push down optimization. Okay, means we cannot achieve the push down optimization on these things and uh, achieve the performance. But in future, as we know, at the IICS level, different releases used to become, and it might be possible in the future. These things will also support the push down optimization. Okay. Then now let's go towards the execution part, okay, and the demo part. So whenever we have to use the push down optimization, we have to enable it at the session level, and then we can use the push down optimization. Okay. So we can also preview the uh, video asset at the mapping level. Here, if you click on this particular three dots, you will get the number of option here. And in that number of option, if we click on the push down optimization preview, push down optimization option, we can also get the preview of the asset at the push down, preview of the option at the uh, that particular mapping level. Okay. So when you do the preview, here also we can get the idea key whether the push down optimization will be succeed or not. So when you do the preview, there should not be any error. Okay, at this level. And if any warning, that warning is acceptable. Okay. So let's see the demo of these. Okay, then you will get the clear idea what exactly we have discussed till now. Okay. Now, as I said, whenever you want the particular pull down optimization to use in your whenever you want to use the push down optimization for your session, then you have to do what? You have to enable it at the session level. So this is my mapping. Okay, this is the mapping and push down optimization. Now same mapping I have used in the two sessions. So this is the first session. You can see this is the session where I have enabled the push down optimization. Okay, so let me show you. So if you go to the edit and schedule, so if you want to use the push down optimization, here you have to enable the push down optimization. Here you can see. Okay. And now from here, you can choose which type of push down optimization you want to apply. Now you can see, as I said, the partial PDO is not supported in the IICS. So here you can see the uh, only the three options are available, like two source side push down optimization, two target side push down optimization, and full push down optimization. And if you want to use the parameter file, and from the parameter file, if you want to pass which push down option, which push down optimization type to use, you can also use this parameter in the parameter file, and here you can provide the value, and then that value is nothing but what type of the push down optimization you want to apply. So using the parameter file also, we can select the push down optimization type. Okay, that also I will show you. Okay, so if you want to apply the pull down optimization, you have to enable it, or you have to select it from here. If you don't want, you can select the none. But here in this session, name of the session SM push down optimization means for the experimental purpose, we are using here full push down optimization. Okay, and we'll finish. Okay, now we have to do the comparison key what happen when we apply the push down optimization and what happen when you don't apply the push down optimization. Okay, so we have the another session here, same mapping. You can see here also m push down optimization, here also m push down, same mapping I have used, only the I'm changing the property at the session level. Now in this I don't want to apply the push down optimization, so here you can see I have not selected any optimization type here. Okay, now let's finish it. Now first let me show you, as I said, we can preview the video asset at the mapping level also. So if you want to do the preview, you can go to this option, push down optimization panel, and preview push down. So this preview must be success. Okay, this preview must be success. As you can see, the push down optimization type full. Create here to this option also we have to enable. So create temporary view in the sense it will create the temporary view of object at the database, and create temporary sequence. It will create the temporary sequence of your create the temporary sequence object in the database. Okay, so we have enabled these two options also. Now we will click on the push down preview. Now this preview must be success, otherwise our push down optimization might be get failed. So here we will check. Okay, our preview is running. Let's see whether it is succeed or not. So now you can see it is success. So our push down preview is success. So when it can get fail, when there are some transformation which we have used, like here, if there are some transformation in this pipeline which are not supporting the video, that time our preview might get failed. Okay, but here you can see our preview has got succeeded here. Okay, now we have to compare the two session. One session we have enabled the video. Okay, in this session we have enabled the video, as already I shown you here. You can see full video, and there is a one more session where we have not enabled the video. Here you can see none. Okay, now let me run the session and let me show you the performance of sessions without video and with video. Okay, so first I will run the individual session, and after that I will run the session in the workflow also. So this is the SM push down optimization. I will run this and let's see how much time it is taking. So it started running. Let's see. So you can see it has completed within a 27 seconds. and number of rows which are loaded at the target are 2,30,475. Now now next we'll run the another session. Now here we have not applied any kind of video. Now let me run this. Let's see how much time it will take. So in the session where we have applied the push-down optimization, our ETL load time is 27 seconds. Now we have to see the session where we have not applied the video. What is the ETL load time? Okay. Okay, so this is a SM non-push optimization which is still running. So you can see it has taken the 53 seconds. So you can see the 50% amount of time is increased if you don't use the push down optimization. As you can see here. So this is the session we have run where the PDO is enabled. Okay, and the time taken for it is how much? As you can see, the 27 seconds. Okay, and another non-push down here is going to say time taken is 53 seconds. So you can easily see here our time has reduced from 50%. So it is depends on data. We can achieve the more than this performance also. Okay. So that is the power of push down optimization that you must have understood now. Okay. Now let me show you the logs also. So this is the logs of session where we have applied the push down optimization. So in that I will show you our push down optimization has succeeded. Okay, so if you go into the logs, you can control F and okay, here you can see the transformation. Now in our mapping we have the expression transformation. So you can see the expression transfer will be pushed to the target. Okay, means your expression transformation will get converted to the SQL query and it will be get executed by the target database. Then filter transformation. So filter will be pushed to the target. Okay. So here you can see our push down optimization has finished. Okay, and it has been successful. Okay, so in this way you can see the logs also, and in the logs you can see in the logs as I shown you. Let me show you once again. As you can see, whether your transform logic is pushed toward the source or target, you can also cross check here. Okay, so this is about the our session where we apply the push down optimization. Okay, now we can also check the performance by putting these two session in the parallel path in the workflow. You can see here, this is the non-push down, this is the push down. Okay, and let me run this. Now this will run, this two session will run parallelly, where in the one session push down optimization is enabled and in another it is not enabled. So let's see the performance. Here also we can cross check the performance of push down optimization. So this is the session So this is the session where we apply the pushdown optimization, and this is where we have not applied. Okay, so let's see. So this you can see our session where we apply the pushdown optimization has executed before the session where we have not applied the pushdown optimization. So let's see the time. So the session where apply the pushdown optimization time requirement is 27 seconds. And the session where we have not applied the pushdown optimization time is the 59 seconds. Okay, you can see. So in this way, we can use the pushdown optimization and improve the performance of our particular jobs or the asset which we are running in the Informatica side. So this is all which we have discussed till now. Now you must have got the idea about what exactly the performance tuning and what exactly the pushdown optimization in that. So as you can see, the ETL load time here in case of this job which you are run. So here in case of pushdown optimization enable session, ETL load time 26 seconds. And in case of the session where the pushdown optimization is not enabled, it is 59 seconds. Okay. So here when we apply the pushdown optimization, our ETL load time is better. And when you don't apply, our ETL load time is higher. Means our performance is not as expected. So that is all about the pushdown optimization and the performance tuning. Okay. So if you have any doubt, you can put in the comment section. Okay, I will definitely reply. Okay, thank you all of you.